All right, last video in the functional group series. This one is aromatics. This contains the ring that is six-sided cyclohexane, but there's a double bond alternating structure, which makes it a unique type of cyclohexene, and this is called benzene. So again, a six-carbon ring with an alternating double bonds is called benzene. If you change out, and now when I draw this, I'm going to draw real quick. When you draw this, you have these alternating double bonds, which means that there's only one additional connection needed on these carbons, and they're usually filled with hydrogens. Now, when you change out one of these hydrogen groups, then it becomes a phenol, or a phenyl, as indicated here. And if one of those swap outs is an OH, then it becomes a phenol. You are going to attach whatever item on carbon number 1, and then you follow it with the name phenyl. Sometimes you'll see the name benzene, but phenyl is typically the one that follows. So because you have a ring structure, you have lots of places that you can attach, and you can number them 1 through 6, and there is nothing wrong with that. But you will also see some other naming strategies. You'll see ortho used, meta, and para, especially when there's two connections, meaning you start with the X, and if you have two adjacent substances, you use ortho, or you could call it 1,2 or 1,5. And if you have where you skip a carbon, this is when you do meta. It could also, so back up here, I'll go 1,2, and this could be 1,5. You can also have meta, which is 1,3 or 1,4. Nope, 1, 2, 3. Wait, this is a 6. I'll get it right in a minute. 1, 6. This is a 5. And then para is when they're opposite each other, which is a 1, 4. Okay, another way to show benzene rings that is unique to benzene rings, I drew this version on the other screen. This is the uncondensed version, or the full structure. These double bonds, because it's free to move around, it has a resonance, meaning that the double bonds could be in any of these positions. So benzene rings are also illustrated with a circle, meaning this means that there is a double bond every other line. And depending on the positioning of the benzene, you're not sure where it's going to be. So let's look at some of these. Now, in this example on the upper right, we have our benzene ring, and we can see that we have a position here 1, and this would be in position 4. So this is 1,4 dichloro, and they call this one benzene. So 1,4 dichlorobenzene. You could also call this para dichlorobenzene, and that would be acceptable. Over here on the left, we have our phenol ring or benzene ring, and we have a, let's see, so we're going to go 1, 2, 3. So this is 1, 2, 3, and 4. So we have our 1 phenol, or 1 phenyl, sorry, 1 phenyl. And then we have a butene. Let's put a number in there because we need to say where the double bond is. We have 2 butene connected. Okay, so we've got our phenyl group, and off of the carbon 1, we have another chain. We have a butene. We have that double bond there at position number 2 attached to it. So let's look at the one on the bottom here. We have a phenyl, and it would be in one position. And I'm going to move that because I don't think it's going to do well with our what I have to write all for it. So 1 phenyl, and we have attached to that, we have our 1, 2, 3, 4. We have another 4 carbon chain. But in all the research that I've done, this one was listed as a 2 butene ahead of the phenyl. So 2 butene, and then it had a 1, 4 diol, meaning there's 2 hydroxide groups there. Okay, so this was 2 butene, 1, 4 diol, 1 phenyl. Again, I see the discrepancies between this version and this version of the order. I think regardless of how you read it, you can put it all together and get the same structure. Now this is a whopper over here on the right. And in fact, I'm going to change colors because I think I'm going to run out of room when I write this. But I have my phenol group here in the center. Okay. I have, because it has an OH group attached to it, that's my phenol. So that's the last thing that I'm going to list because that is the most, that's the end part. I have a branch here and I have a branch here, which also includes this whole big structure. So this first branch is easy. We have 2-methyl. And then we have on carbon number 1, 2, 3, 4, on carbon number 5, I have my whopper. And they put those big ones in parentheses. So I have here, I start with, I have a cyclopentane. See, I have a cyclopentane, and on carbons where it's attached, we're going to go 1, 2. We have 3 methyls, so I have 1, 2, 2, hyphen, trimethyl. And then I have my cyclopentane. Told you I was going to run out of room. And that's a closed parenthesis. So that's 2-methyl, 5, 1,2,2 trimethyl cyclopentane phenol. So you can see that as we add different things to these functional groups, to these molecules, and they keep getting bigger and bigger, you have to have a very descriptive way to name them. And so hopefully this all will make sense at the end.